What if another star replaced the sun? Imagine waking up one morning and looking to the sky. The sun, the warm, life-giving heart of our solar system, is gone. In its place, something else burns, a new star. Its light floods the Earth in unfamiliar colors. Its heat sears or freezes. Its gravity pulls at the planets, tearing the solar system apart. This is not science fiction. This is science. And tonight we ask the question, what if another star appeared in the sun's place? The sun is not just another star, it is our star. A G-type main sequence star, stable, middle-aged, perfectly balanced. It provides the exact amount of energy needed to keep liquid water on Earth, the exact gravity to anchor the planets, and the exact lifespan to let life evolve. Remove it, and everything you know ends. What if it were replaced? What if another star appeared exactly where the sun is now? Stars come in many forms: massive blue giants, tiny red dwarfs, collapsing remnants. Each has its own rules, its own dangers. If the sun were replaced by a red dwarf, Earth would be bathed in a dim crimson glow. The planet would quickly freeze, starved of heat. If replaced by a blue giant, Earth would burn under ultraviolet fire. Radiation would sterilize the planet to bones. If replaced by a neutron star, a stellar corpse, small but impossibly dense, the solar system itself would be ripped apart by its crushing gravity and searing radiation. Every type of star brings catastrophe. But why? To understand, we must compare. The sun is average, and in that averageness lies perfection. It shines with a stable 5,778 Kelvin surface temperature. It balances nuclear fusion against gravity, creating steady light. It orbits in the quiet arm of the Milky Way, and it has endured for 4.6 billion years. Other stars, they are extreme. Red dwarfs live trillions of years, but they flare violently, blasting radiation. Blue giants burn millions of times brighter, but die young in cosmic explosions. Neutron stars compress the mass of the sun into a sphere just 20 kilometers wide, bending space itself. Compared to these, our sun is the rare, gentle exception. So, what if, in a single instant, another star appeared where the sun is now? Let's walk through it. Step 1. The switch. In the first second, Earth would not even know. Light takes 8 minutes to travel from sun to Earth. For those 8 minutes, everything would be normal. But then, the sky changes. Step 2. Radiation shock. If a larger, hotter star appeared, radiation would arrive like a flood. Ultraviolet light, X-rays, even gamma rays. The ozone layer destroyed. The surface sterilized. If a cooler star appeared, the opposite. Temperatures plummet, oceans freeze, life suffocates in the dark. Step 3. Gravitational chaos. A star is not only light, it is gravity. Replace the sun with a star twice as massive, and Earth's orbit collapses inward. Replace it with something smaller, and the planet drifts away, casted in frozen reaches of space. The orbits of every planet shatter. Jupiter may collide with Mars. Saturn's rings may disintegrate. The solar system itself is torn apart. Step 4. Long-term collapse. Over days, months, years, the planet changes forever. Atmospheres stripped, magnetospheres fried. Seas boiled or locked under ice. Life, if any survived the first moments, would face extinction. The lesson is clear. Our sun is not replaceable. It is not ordinary. It is extraordinary. In the vast universe, stars number billions. Yet so few create conditions as perfect as ours. So few last long enough to let civilization rise. We are here because of a fragile balance. One star, one violent, unpredictable, and vast, and yet, against all odds, we exist. Which raises a final question. If our sun is so rare, what other impossible worlds might exist, orbiting stars beyond our reach? Next time, we ask, what if Earth had rings like Saturn?